Hi, I'm Paul Brodie. This is my shop. The man holding the camera is Mitch. Thank you for joining us. And we're going to work on some parts for the Romax today. I'll be making a Romax and I need brakes. We're going to make some U-brakes, not today. Today we're going to focus on the lever. So I have a selection of levers here. I got 6 of them. And I've done some research. I've measured the distance from the handlebar out to the pivot, the distance from the pivot to the end of the lever. There's a bunch of dimensions I've measured. So these are my notes. And I've also made some sketches. I don't have a drawing. I'm just going to start making. And I settled on number 4. So if you zoom in here a little bit, you can see there's the 2 parts. This is known as the perch. This is the lever. And I've got an outline in red because I've got the perch inside. So that's the size of the aluminum I'm going to be starting with. So I have 2. I have to make a right and a left. And I've made lots of things, but I've never made a lever. So the first step is to make the hole that holds the bar, the handlebar. So we're going to put this in the mill. First I don't want to drill down and bore into a blind hole. So what I'm going to do is I'm going to go to the bandsaw and I'm going to use the bandsaw and cut out a notch here, so that when I bore down, at least the chips can escape out the side at the bottom. That's first step. In this process, I have to hold this. All these steps I'm going to be doing, I always have to think, how can I hold it? That's why I don't cut the shape out right away, because then I got no way to hold it. It's always crucial. How do you hold it in machine shop terms? Okay, let's go to the bandsaw. We're going to cut those notches out. I didn't mention it, but this is 6061, and these 2 pieces of aluminum, yesterday they cost me $15. I'm going to use a digital readout so I can center it, but this just lets me know how close I am, because it's always possible to make a mistake. I got a few operations to do here. So what I'm going to do is I'm going to set this up in the mill vise, and I'm going to locate it against this at the end of the vise, and then I can swap them out because each of these pieces is identical in size. So I can drill the hole, swap it out, I'll drill the next size hole. Then I don't have to keep on changing drills as I go through, just doing one at a time. Looks like it's very close. Well, close to my felt pen marks. So now I can just swap parts back and forth, because when I do it like this, I know it's going to be right where the other one was. We'll have to slow it down a bit because this is a larger drill. That's the rule. A small drill bit, you go very fast. Larger drill bit, you go slower. I'm going to try 800. Okay, 750. Let's see what happens here. Oh yeah, that's working. There we go, that worked fine. That's my boring bar. It's a single point tool, carbide insert. You got the vernier scale there, you can adjust it back and forth. That's how you set the size of the hole, because the hole has to be accurate. Otherwise the handlebar won't go in, or it'll be a sloppy fit. Yeah, that's all I want to do. So I'm going to set my vernier to 875. There you go, 874. Zero it. And we'll see where I'm at here. Okay, so it looks like about 60 thou small, which is good. That's 30 thou. So I'm going to take a cut. Yeah, you can see the chips come through the hole. Okay, see the spiral inside there? If I take one more cut and don't move the tool, I bet it takes a couple thou out. So I'm just going to do that quickly. Just taking a very small cut. So once I measure that, then I'll know how much to move my tool. It's a smoother cut now. You can see the difference. That's a smoother cut because it's taking a very small amount. I got my telescoping gauge. So I put it in, lock it, move over center, then measure. Okay, it's 853. So 22 thou. That's how much more has to come out. I'm going to go 20 because I can always take off 2 more thou. So I moved it from the 60 to the 80. It just goes on. There you go. Maybe a little bit of slop, but that's okay. Hard to take the burr off the inside. That'll happen later. Okay, so that's the first part of the operation done. I think what I want to do next is to drill and tap the hole for the adjuster screw to go in here. There's my 0. It's 11 degrees. I've got to hold this in the vise at 11 degrees, and I got to mill a flat. That's going to be that flat right there, because I can't drill a hole if it's at an angle, because the drill wants to wander. So I have to machine that flat. So I think that's the first step, is to mark this at 11 degrees and then hold it in the vise. Like I said, I've never made a lever before, so this is new for me. So I'm learning the process. So I'm going to eyeball to that red felt pen. The flat has to come past here. So that's about where I want the end mill to go to, or the cutter. So it ended up a little higher than I thought. So what you can do for that, if it ends up higher, I take a piece of flat bar. See that? I put the flat bar on top of the vise jaw, and now that lines up quite nicely. This is my fly cutter. It's got carbide inserts, 5 of them. And I usually spin this at about 1,000 RPM, something like that. So what I need to do now is I've got the center, there's the center right there. So I need to mark the center on the piece. All the CNC guys are probably just cringing right now. So that's my center right there. That's where I want to, I've got to drill and tap right there. It's already centered on the mill because I got my Y zeroed, so I just need to move the X so it's in line. But maybe I want to notch this out too, so I'm not going into a blind hole. So I'm going to hacksaw. There's the hole. I'm going to hacksaw like that. There we go. So I'm going to start the tap and then I'm going to switch it off and I'll finish it by hand. There we go. Okay, those are the chips coming out of the tap because it's a spiral point tap and it always forces the chips down. And that's another reason that I didn't want to have a blind hole, because this way I can get the tap to go all the way down and not get bound up with a whole bowl of chips. There we go. I think what we'll do now is to cut the pivot, is to drill the pivot hole. I'm going to show you this. I've got some little pivot, I call them bearings. It's like a little nylon bearing, and this comes out of a trials bike. This is the brake lever on a trials bike that I own, well, an old lever, and you see how the insert is pressed in. So what's going to happen is these little inserts are going to go inside the perch. They're going to go on each side and get pressed in, and then there'll be a little shaft that goes into the lever. That's going to be the bearing. That's a nice little way of doing it. So I'm going to measure off of this here, and how you set this up, I just do that. So that's going to go right about there. I just have to mark one, because after I've marked one, the other one is a no-brainer. Like that. That's my center on the pivot, or for the pivot. So I'll put that into the vise, I'll drill through, and then I just put in this one here, and it automatically goes to the same spot. So we've got to cut the slot now, and the slot you can see on these ones how it comes in at an angle. Can you see that? That's basically what I want to do. I don't like the width of these slots. There's a lot of things on these levers that I don't like. I know I'm fussy. You see how wide it is there? This one is narrower, but I've got a little slotting saw that's even narrower than this. It doesn't have to be that wide. Look at that. Look how wide the motorcycle one is. It's huge. It's got to be at least 1/8 of an inch. So what I've got, I'm going to see if this works. See how skinny that slotting saw is? When it goes into here, it's even got a little bit of a wiggle there. So let's see, and this one's going to work quite nicely. This is a custom holder that I made for a job years ago. See how it goes in? You got to have space here. If you've got a big nut coming down there, it won't go in there. So this might be the trick. I need to set this up in the mill so that I get this the right distance from the handlebar out to the center of the pinch bolt. So there's the center line. Okay, now we'll put this back in, and I'll show you why this piece is in there. So if I put a 5mm drill in, that's the size of the Allen screw, and this is the tap drill. So if I put this in, that's what I'm looking for. I'm looking for that space. So I can make it a little less. I can move this a little bit. That'll be fine. As long as there's a little bit of clearance. So I'm going to lock the table there. So what I want to do here is only go down a little bit, and I might leave a tiny little flat on here on the low side. That shows that I haven't taken off too much. You see how I left a tiny little flat there? Tiny, tiny. We have to go to the drawing. We have to figure out how far down the tap drill is going to go. See, hopefully this is all to scale pretty well. I know it's not a CAD drawing, but I think it's pretty close. So if I measure from that flat, there's the flat, down to the red mark, I get 735. So on the digital readout, I touch the drill, and then I zero the Z. This is Z. This scale here is Z. 735. So I'm going to swap out. I'm going to use the 5mm drill now. See how this comes down? Like that. Comes down. So basically this one, I need to take away that metal, and I need to take away that metal, because that's how the slotting saw is going to go in there. If this is right across like that, like it is right now, that won't fit. I'm figuring out how much has to come off each side. So 267 thou. Need to make a mark here, because this is all going to this is going to come down like so. Have to cut that off, because once I cut that off, then I can cut the slot. I can't cut the slot when all this metal's there. And then I'm going to start right about there. So here's my zero. I zero it out right there. That's my first cut. I go around one turn, that's 100 thou. So the next thing is to make a slot in there. So I have to calculate how far down the slotting saw goes, because I got to have enough material under the head of the Allen screw. I don't want too much, I don't want too little. About 1/8 of an inch might be about right. Off my technical drawing here, say 145. So I need to go down 145, and then I've got the width of the cutter, say 45. So I need to go down 190 thou when the bottom of the cutter is level with that flat spot. See those tiny little chips there. So I would say that cutter is right where it needs to be. So I'm going to make sure this is locked. Then I'll move this. I'll set this to 0 again. And now I'm going to move at 190. There's 100. And there's 90. So that should be in the right spot. See, when I'm up there, I got lots of clearance. I'm watching the space in between the cutter and the piece. I'm watching to see I don't go too close. So once it's out, you can see how the slot goes all the way through. It's a very small slot. I like that. And that's going to work fine. I think the next thing I'm going to do is to cut this off in the bandsaw, and then I can hollow out that, because then I'm still holding it here and here, because I've got those two flats. You know, sometimes when I'm working on something and I need the shape, I'll cut it out with a pair of scissors, and then after I'm all done with that, I'll put it back on the table and I'll use masking tape on the other side, and I'll put it back together. And I guess I can cut this off too. But I'm going to leave a little bit extra on here, and there's a reason for that, because I want the lever and the perch to match perfectly. Okay, that's my bandsaw mark. So it's supposed to end up at about 5/8. Oh, 622. 5/8 is 625. So 3 thou under. That's the width of a thick human hair. I'll go with that. Next we have to make a slot in here. There has to be a slot coming through there, because that's where the lever fits into. Okay, so now I know how far down the end mill can go, because that's going to be my edge. So that's the end mill I'm going to use. It's I think it's a 3/8 end mill. It's heavy, so it's carbide, and I can take a pass like so, and then move over and come back the other way. So what I need to do is to set up the angle here, because I'm going to hold that in the mill at about that angle, so that when I go straight across, I'm going to mark the angle, and then I'll know exactly what I want. So if I set it up to that angle right there, leave myself a little bit of room there so it doesn't get too thin. That's how much, it's about 1/8 of an inch. And I can always hacksaw a little bit on the inside of this line. So that's the angle. So if I put that on top like that, a little bit of space, so that means I can go to about, if I go to about right there, that's probably fine. So that's how far I want to go right there. That's my X0. I take one more cut down, and then I go like that. That's the pattern after that, because I need to widen the slot. So the middle is just a little bit over 3/8 of an inch. So that's enough to make a strong lever. I can go with that. If I hacksaw out this shape right now, I can still hold it here. I always need to hold it somehow. Okay, so we're facing off the perch. Oh, Yeah, this one's smaller. Huh. Now I have to redo the other side to compensate. Okay, we'll go back to this side now. There we go. There we go. Got Anchor Lube. It's a tapping compound. It works really well on aluminum. And because I got the 5mm first part, it goes naturally to its path. This is the rotary table. I'm going to put a 1/4" end mill in there. We get a round 1, 2, 3 corners. This one here, I'm going to come down and we'll see how that matches up. Don't know right now. Okay, let's see what happens in the chuck. So that's, I'm going to zero. I'm going to zero the Y. So that lets me know, because I can't take it all at one cut. So I need to take a couple cuts anyway. There we go, we're taking a cut. It's going to miss a little bit, then it's going to do the next corner. And I'm not sure what's going to happen here, but we'll find out. There we go, you can see better now. Oh! Okay. So we can't take that much of a cut. Oh, I see it. I didn't lock the table. And so what happened was it grabbed and it pulled the tool in. My mistake there. So I'm going to have to be careful on this one here, see what happens, because I don't want it to gouge in. Oh, nothing happened there. Okay, so we're going to move in a little bit. That's the gouge when it started to chatter. Doesn't look very good, but it's going to come out, because we got more metal to take off. And I'm going to be sure to lock the table. So this should take out the gouge. Okay, this one's a tricky one because I'm going to have to blend it by hand a little bit afterwards, but I want to take something off anyway. But I don't want to go too far. And I don't think I want to go more than that. See, there's a flat spot, and there's another flat swell. So you can kind of tell how much has to come off by the width of the flat spot. So you got a larger flat spot here than here. So I have to be careful. This is kind of a fussy thing. So I'm going to move the tool in a little bit. Yeah, I don't think I want to go too much more there. I think that's as good as I can get it right now. Let's take it out and have a quick look. So that's a nice radius around there. That's going to hold the bar. You can see the shape of the lever. It's going to get radiused here, radiused on the outside. When the lever's made, that'll be next week. When I make the lever's going to be held in here, then it's going to get all filed. So the lever and the perch are going to match perfectly. So that's what's gone on. I hope you like this, watching this. Thanks for tuning in. See you next week. Stay safe. Thank you.